In order to estimate the vulnerability of the European Union as a whole to a disruption in raw material supply, the European Commission developed a methodology that relies on a certain number of influencing factors, some for economic importance of mineral raw materials and others for material supply risks, with specific equations as illustrated in the slide. While there is no time in this video to explain all the parameters in the equations, one of them will be examined during the hands-on exercise following this video. First, information is collected for a variety of items, for example, which applications use this raw material? Are these applications important for the European economy? Is there a monopoly in terms of production of this raw material? Can this raw material be replaced by another in these important applications? That's called substitution, etc. Following the answers to such questions, the different factors are assigned numbers reflecting their relative importance. Using the equations, the numbers are combined into two estimators, one for economic importance and one for supply risk. These two estimators are then plotted on an XY graph, and a threshold is defined to highlight which raw materials can be considered critical. Here we see the results of the European Commission's criticality analysis published recently in 2020. It highlights which raw materials are considered particularly critical for Europe. For example, light rare earth elements, especially neodymium and praseodymium, that are used to make permanent magnets found in electric vehicles, wind turbines, etc. Heavy rare earth elements, especially dysprosium and terbium, also for magnet applications in the energy transition. As mentioned previously, rare earth production is largely dominated by China, and that introduces a factor of risk for supply. Magnesium for special light alloys, used for example in transportation to reduce weight and therefore to consume less fuel. China also dominates magnesium production, actually 82% of global production in 2019. Niobium for high-strength steels. Niobium production is dominated by Brazil, with over 88% of global production in 2019. Germanium for efficient solar cells, etc. The European Commission updates its critical raw materials list every 3 years or so. 3 raw materials that were not considered critical in 2017 list are now considered critical: bauxite, lithium, titanium. Lithium, for example, is an essential material for lithium-ion batteries, and with the development of electrical mobility, the economic importance of lithium has been upgraded in the new 2020 evaluation.